This video is brought to you by Springboard. If you're considering kickstarting a new career in machine learning, Springboard has helped its graduates do just that. Tracks for going from developer to proficient data scientist are among the many options offered. Springboard allows you to learn in-demand skills with online courses and provides mentoring by industry professionals. Springboard prepares you for rewarding jobs at top employers. Certain tracked programs include job guarantees, and many of the graduates have landed jobs at companies including Google, IBM, Visa, Salesforce, and many more. Check the link in the description for more information. We're going to be using TensorFlow and Python to solve a given regression problem. And the regression problem that we're going to solve is going to make use of this auto MPG miles per gallon data set that we have here on this page. And this is basically a data set that contains a bunch of different cars, their respective miles per gallon, so how many miles to the gallon they get for gas, and then a number of attributes about each of those cars. So for instance, what's the horsepower, how much does the car weigh, when was the car produced. And what we want to do is we want to figure out, given all of these attributes, not including miles per gallon, can we predict how many miles per gallon a car has based on these other attributes? How accurate of a model can we create to predict this quality? And as we've seen before in other videos on this channel, we've dealt almost exclusively with classification problems. So just to kind of differentiate here, because this is important differentiation, a classification problem is one where we want to select a class from a list of classes. So an example of that is maybe we want to figure out whether or not a picture contains either an apple or an orange, and we want to ask, hey, what fruit is in the picture, knowing that those two classes are appropriate, predefined classes. And we've seen this when we've treated the fashion and NIST data set when we were trying to classify an article of clothing. We've seen this when we were trying to classify text. So we've dealt almost exclusively, especially with TensorFlow, on classification problems. So unlike that, regression problems, we want to predict the output of a continuous value. So a continuous value is something like a price or a probability. And we can see here that this, I just want to say maybe a little bit of the machine learning repository if you're not familiar with it already. This is where this data set is coming from. And if you want to kind of get let's just say more practice with any techniques in machine learning, if you want to kind of create other applications based on some, let's just say, more isolated data sets that are very well known, you should check out this website, which I will leave a link in the description for. So there's a lot of data sets that might pique your interest a little bit more. A lot of these are very widely used, so there's a lot of articles and YouTube videos in addition to this one that deal a lot with these types of data sets. And if you want to kind of get more of a sense of what you can do, what you can predict, what you can build with these things, I think that there's a lot of information out there, and this website is really great because a lot of the data is very clean, almost unnaturally clean in what you would get in any real life scenario, but still it gives you a nice, it takes the data preparation part of machine learning out of the equation and allows you to just focus on how to build your model, how to understand the data, how to classify the data if it's a classification problem, etc. So going back to this particular data set, all of the data sets on this website are going to have kind of a breakdown of what the data set actually consists of. So for instance, we see here that associated tasks, well, it says there right there that we're dealing with a regression type of problem. How many instances, so how many entries of data? It's a fairly small data set. We only have about 398 entries of data. So you're probably not going to get a model that's very, very good on such a small data set, but we're going to see what we can do with that. Number of attributes. So this is like these are the attributes of the data set. So for each entry, it has the miles per gallon, how many cylinders, displacement, horsepower, etc. Each of those are the attributes, and there's 8 of them that come with this data set. It lets you know if there's any missing values. So oftentimes, especially in the wild, when you're dealing with data sets that you want to actually analyze and derive intuition from, the the data set is not perfect, it's not pure. You're going to have entries that are not there. You're going to have some acquisition of the data didn't go as planned, so you're not going to be dealing with a complete picture. So there are missing values in this particular data set, and how you go about dealing with those missing data is quite a subject unto itself. It's quite a complicated topic. So we're going to take kind of a naive approach to dealing with that, especially because the data set's quite small. There's not many missing data, as we'll see. But this is something that is important. It will most likely skew how your model is, is actually used to apply to the data set that you're trying to build a model for. other information like when the date was acquired for this data set, etc. A little bit of high-level information about when it was acquired, how it was acquired, some more information there. We saw the attributes, and then if there's any relevant papers that feature this data set or cite this data set. So it gives you kind of a high-level view about how this data set is actually structured. So what we're going to do is we're going to create a Python script that's going to read in this data set. And the nice thing about that is you can make use of TensorFlow to do that. We're going to read that in, and then we're going to make use of a few other modules like pandas and matplotlib and seaborn to actually plot some of these things to get kind of a sense of what we're dealing with. So let's go ahead and go over to our Python file and do just that. So right now what I have here is I just have an empty file. It's just a Python file that I've created. You can use whatever editor you like. I like to use Vim. If you like my Vim configuration, the link to how I configured Vim is going to be present in the description of this video. You can customize it to your liking. You can use Sublime Text or Idle or any of those other programs as well, whatever you're comfortable with. So what I'm going to be doing is I'm just going to first clear the terminal so the output for whenever we run anything is going to be, it's going to be nice and clean. And then what I'm going to do is I'm going to copy and paste some imports that we'll need. And I will step through each of these so that way we're 100% on the same page. I want to keep this as self-contained as possible. So what I've just copied and pasted over are the modules or Python libraries that we're going to be making use of in this specific video. I'm going to step through each of these. If you don't have these installed, we'll install them together. If you followed along in any of the other machine learning videos on this channel, you probably have most of these installed. So I'm just going to assume that you have Python and 3.6 plus preferably, and also pip. So pip is Python's package manager. So long as you have both those installed, you're good to go. So I'm just going to step through these very quickly. This first line here is just kind of a backwards compatibility line just to make sure that this kind of works with other versions of Python. You can more or less ignore that line. You can have it in there and just kind of forget about it. The next one, pathlib, this is something we'll have to install. We're going to make use of this later. Matplotlib, this is used for generating nice graphics. Again, if you don't have this installed, we will install it. Pandas, this is going to more or less be used to actually reading in the data, manipulating the data, and treating the data in these objects or these data structures called data frames. If you haven't dealt with those before, we'll see what those are. Seaborn is another plotting module, which is kind of nice. And then, of course, if you clicked on this video, I assume you know what TensorFlow is. So TensorFlow is a Google solution that exists in Python, but also other languages, that allows you to have very high-level access to a number of different machine learning types of objects that are very useful in this space. So we'll see how to make use of that. So first, before we need to run any of this, we need to install it. So I'm just going to say pip install pathlib. So I'm just going to kind of go down the list here for the things that I've imported that don't come standard with Python, and just go ahead and do pip install. So I'll go ahead and do that with matplotlib as well. So if you already have these installed on your machine, you'll probably see messages very similar to my messages that you're seeing right there, which is that you already have these. And if you don't have them installed, it will go ahead and install them for you. I just did a pip install of pandas there. I'll do a pip install seaborn. So this is going to install seaborn. Again, I have all these installed, so you probably will only need to do this if you don't have this installed. If you already have all these modules installed, you can skip this part and you're good to go. Now, just to make sure that we actually have everything working properly, I have this line here that just prints out the version of TensorFlow that I'm using. This is just kind of to print it out to the screen. If we don't hit any snags when we import any of these modules, that's good, because it will kind of complain like, hey, I don't know what this is, if you don't have it properly installed. And if you get all the way to this line, it prints out the version, you're good to go, you've got everything you need. So go ahead and say, write that, and say Python. The name of this file that I've written to is called fuelefficiency.py. You can call it whatever you like, of course. So I've gone through all the, apparently I have everything installed just fine, and the version of TensorFlow that I have is 1.13.1. So of course, depending on when you watch this, that might change. So I'm going to comment that out, because that's really just kind of a sanity check to make sure that this is going to work as expected. And now the next step that we want to do is we want to actually get the miles per gallon file. So what I'm going to do is I'm going to use Keras, which is part of the TensorFlow module that we imported, and I'm just going to go ahead and kind of paste in this line, and I'm going to, oops, not save it, I want to paste in this here. There we go. So I'm going to format this so it's a little bit nicer, because it kind of runs off the screen here. It looks a little bit ugly. I can't really do much about that URL, but I'll just leave it like that. So what I've done is I've created a variable called dataset underscore path. This is going to be the path to where we're going to save the dataset that we're going to download from that website that we were at before. So I've created that variable and I've said keras.utils.getFile. So this is a module that's provided to us from the Keras API. If you're not familiar with Keras, it's another machine learning solution that TensorFlow provides an API to, and we're essentially making use of that to get a specific file from a location and then save it on our computer. So we're feeding in this initial argument here, this first one, which I've called auto-mpg.data. You can call it whatever you like. This is just the name of what it will save as on your computer. If you don't specify a path, it will kind of default to the dataset's Keras path, where all of the datasets are stored for any time you make use of any other Keras dataset. If you've seen other videos on this channel, you've dealt with that as well. The next argument here is the place where we're actually going to go fetch the data. In this case, this is this URL here. And I got that URL by checking out this link here, going to the data folder. All of the datasets are going to have a respective data folder, and then copying and pasting that link there. So just copy that link location, went back to the to essentially the function, and then pasted that URL there. And that's exactly where it's acquiring that data from. So it's going to grab that data from that URL. It's going to store it in that file name auto-mpg, and then we're going to have access to that path from the dataset underscore path variable. So if we go ahead and run that, it's going to download it and store it there. So the next thing that I want to do is I want to actually import that data that we've downloaded, and I want to import it into a pandas data frame. So the first thing that I'm going to do is I'm going to create a list in Python, which is just going to be a list of the attribute names. So just so you don't see me type all of those out one by one, I'm just going to go ahead and paste that in. Nothing special here. It's just a Python list called column names, and each of the entries, as you can see, are just strings. They're just the names of the attributes, which I've just, if I go back here, they're just the names of each of these attributes here. So just close that. So MPG, cylinders, displacement, horsepower, etc. So going back there, you can see MPG, cylinders, displacement, etc. I'm just defining that because I want the heading of the data set to be each of those as defined by this column names list. So now we're actually going to go ahead and create a raw data set by reading in that CSV file that we downloaded from the previous part of this on line 15 there, and we're going to have this so we can actually manipulate this data. So I'm going to call this raw underscore data set, and I'm going to set this equal to pd.read underscore CSV. So this is a function that's provided by pandas, and I'm going to give it a few things. The first is where we want to read the data from. So we've already stored that in dataset path. The next couple things are going to be a few optional things that we can specify. So I want the names or the headings of each of the columns in this data set to be the column names list that we've previously defined. So I'm going to specify that by this optional parameter called names, and I want to set that to column names. So that's essentially going to take each of the columns in the data set that we're reading from, and it's going to tie each of those to the column names list here. The other thing that I mentioned before is we have missing values. If you go to the website here, if you go up, it says that it does have some missing information. We want to see exactly how much missing information it does have and deal with it. We're going to do that later, but for now I want to go through, and anytime there's a missing piece of information, I want pandas to just replace whatever that is with a question mark. And you can do that very easily by this optional parameter called NA values. So you can set this equal to a character that's going to replace any of the empty components of the data set with a given character. In this case, I want to replace it with a question mark. I'm going to specify an optional parameter for a comment to be a tab, and then I want to also specify how the data should be separated. So in this case, the data I want to be separated by a space. Just get rid of that. So you might also have data that's separated by a comma, in which case you would choose the separating character that's going to distinguish each of the different numbers in the rows. So those are generally separated by a space or a comma. In this case, they're separated by a space. And then also one other thing that I want to do is I want to add another optional parameter that's going to skip the initial space. So if you've seen an Excel spreadsheet, sometimes the first row is the column names, right? So MPG, cylinders, displacement, etc. I want to skip this row, and I don't want to treat it numerically. I want to essentially treat that as just the title for each of the respective numbers below it. And in pandas, you can do that quite easily by saying skip initial space, and it's a boolean, so you can set it to either true or false. I think by default it's equal to false. So If we set it equal to true here, we'll skip that first line. So that's all I want to do. Now we have this raw dataset variable, which is the pandas data frame, and that contains, kind of the most rawest form of what we're going to deal with. So the next part of this is what we want to do is actually kind of copy this into a data set that we're actually going to manipulate. And we're going to manipulate it in a couple ways. Specifically, we're going to deal with those missing values. We're going to do a couple other, like, let's just say, data gymnastics to the data set, but we're going to keep the raw data set kind of as is, so we have that to go back to if we want to. So I'm going to create a copy of it by doing this. I'm going to say dataset is equal to raw dataset.copy. So any data frame has a built-in method called the copy method, .copy. So I'm just calling that, and I'm storing the copy of the raw dataset that we created above equal to dataset. And then what I'm going to do, just so we can verify that we actually have the dataset here, I can say dataset.tail. And this is going to print out the last couple entries of the dataset. So I'm going to say write, and I'm going to say Python fuel efficiency. So what this is going to do is it's going to go through all of what we've just written, and then hopefully at the end we're going to see the last couple entries. So if you go back to the dataset here, you see the number of instances, total entries in the dataset, 398. And indeed, if it starts off at 0 indexing, the last entry here is 397. So the tail function is printing out the last 5 entries of our data set that we've copied over. So you can see that it's got like the nice names, the column names that we've created from before that we set to be the title of each of those, the respective column names, and then each of the entries below. So for each row, so this entry here, 393, corresponds to some car that gets 27 miles per the gallon. This one has 4 cylinders, 86 horsepower, etc. So we've got that. So that's what I want to accomplish in this video. In the next couple of videos, we're going to deal a little bit more with cleaning up the data, specifically what we're going to do with the missing values. We're going to explore the data a little bit more, and then we're actually going to get to building a model using TensorFlow. So if you have any questions or comments for this video, leave them in the comment section. The code will be available on my GitHub, and there'll be a link to that as well. So if there's any questions, don't hesitate to ask, and I'll see you in the next video.